create a fully functional dashboard panel in MetaTrader 5, there are three crucial steps to consider. The first step is creating and running a panel inside the onInit function. The second step is destroying the panel inside the onInit function. The third and final crucial step involves creating the onChart event function for detecting and handling all the chart's events occurring. To get started with creating a simple dashboard, let us create an expert advisor and call it Simple Dashboard. Within this newly created file, let us import dialog.mqh5, which can be found under the include folder within the subfolder named Controls. There's no need to worry about where you can get these files. They are native, as they come with the MetaTrader 5 platform. Within the Controls subfolder, there is a lot of files to aid us with the development process. Such files include the combo box.mqh, which contains the code for creating drop-down menus. The edit.mqh file can be used to create input sections. All the files imported in this course can be found under this folder. We start by importing dialog.mqh from Controls folder. We then assign the class CAppDialog to a variable named Dashboard. Inside the onInit function, we want to call the method create from the dashboard assigned class. We pass 0 to draw the panel on the current chart. We set the name of the panel dashboard. We then assign the sub-window value to 0 to indicate that we don't want to draw on the sub-window. For x1 and y1, we assign both values to 20. We'll discuss in detail these x and y coordinates in the upcoming chapters. The ending position x2 and y2 are assigned to 300 and 200 respectively. The create method returns a Boolean value, true for success and false for failure. We can wrap this function within an if statement and return the init failed code to stop the program from further executing whenever there is a failure in creating a dashboard. To destroy a panel, we call the method destroy from our dashboard assigned class. We give this method a reason provided by the onInit function. Inside onInit function, we call the run function from our dashboard class to execute the panel. Due to the complex nature of the code to create a panel and all of its objects in MetaTrader 5, I highly recommend having a debug option set up. Instead of compiling the program every time you make a change, which can be time consuming, pressing the F5 key to compile the program in debug mode could save you a lot of time during development. After compilation, sometimes the panel and some objects could take a long time to display. By calling the built-in method chartRedraw, MetaTrader 5 will reinforce these objects to appear on the chart as soon as possible. Let us compile the program and observe the changes. Suppose we try to perform any action on this panel, such as minimizing or maximizing it, or even dragging it to a different area on the chart. Nothing will happen. This is because we have only created the panel, but we are yet to give this panel, named Dashboard, the ability to understand the actions performed by our computer mouse or a keyboard. This is where the onChart event function comes into action. By tapping the word void followed by onChart event, then press tab to get the autocomplete. We can go from dashboard, then get the method called chart event. We pass to this method all the parameters for onChart event built-in function. This way, all the objects within this chart will respond to any chart event that will occur on our dashboard. After compiling the code in debug mode, our panel becomes dynamic and flexible. An informative dashboard usually displays the text labels. In this chapter, we're going to make it display a few pieces of information such as account name, account daily profits or loss, the percentage equity drawdown, the combined number of orders and positions running in the account, and the market spread. While creating a simple dashboard, we had to code everything within a standalone expert advisor. An interactive dashboard might be too complex and confusing if we decide to code everything within a single file. The right way to approach this is by using object-oriented programming. So let us start by creating a library file named Informative Dashboard. After this new library file is created, we can delete all the comments within it to start afresh. We start coding our class by writing the word class followed by pressing the key tab on your keyboard to get the simple class autocomplete code. We give this new class a name C Informative Dashboard. We then declare a class constructor and a destructor. We then import all the necessary libraries that come with the meta editor. These libraries are built-in, so there's no need to ask where you can get them. The dialog.mqh file comes with a window panel which resembles a container that enables us to add buttons, labels, and many objects to it. Inside the defines.mqh file is where all the macro definitions can be found for all objects in MetaTrader 5. If you'd like to customize the default look of the panel, feel free to modify the variables within this file once you understand how everything works. For our class to work seamlessly, we must inherit a class named CAppDialog from dialog.mqh. This way, we can be able to access all the functions and methods for creating a panel inside our class. We inherit the onEvent function from class appDialog, then override the run method. Let us create a function named createDashboard for creating the dashboard and all of its objects. The string variable name takes the title that will be displayed on top of the panel. An integer variable x1 is the starting position along the x-axis, while the variable y1 is the starting position along the y-axis. A variable named x2 is the ending position on the x-axis, while a variable named y2 is the ending position along the y-axis. To understand this in depth, let us look at the x and y-axis from a graph. Since we can only position objects using positive numbers, our only focus is on the positive side of this graph, on the upper right side. Suppose we want to create a button starting at the initial positioning of xy and y1 both equals to 10. We want this button to reach a certain position horizontally. This position can be labeled as x2. Meanwhile, The vertical position we want our button to reach can be labeled as Y2. The horizontal difference between x1 and y1 represents the width of an object, while the vertical position, which is the difference between y1 and y2, is the height of the object. MetaTrader 5 objects positioning works slightly different. Instead of focusing on the upper right corner of the graph, our only focus is on the lower right bottom of the graph. As said earlier, we cannot have negative numbers for positioning, so we can refer to values on the lower part of the y-axis as positive numbers. This positioning approach does not only apply to the objects, but also to the panel itself. It is crucial to keep track of the panel starting and ending positions on both x and y axes, since the objects have to be arranged manually by you. For example, if the panel starting x1 position is 10, all the objects you want to add to this panel must have a starting position greater than 10. A starting position value less than 10 could cause the objects to appear outside of the panel. The same applies to the panel's ending positions. As we did in the previous chapters, let us define the section in our library just outside the class for handling all the events occurring on the chart. We call the event map begin method and pass to it the current class followed by the event map end, which is given the parent class. By mapping this way, we ensure that we start monitoring all the objects starting from the ones we will create in this class all the way up to the objects provided by the app dialog class, which comes with the panel object. Inside our class constructor, we want to reassign the value mChartID from the dialog class, giving it the value of 0 to explicitly draw the panel on the current chart. We also reassign the mSubWin variable, which is a variable that keeps the information of which sub-window our panel should replace. By assigning this variable to a value of 0, we ensure that the panel will not be drawn on the sub-window, which is a place for indicators mostly. Now let us declare a function to create our dashboard. We call the create method from the parent class, giving it the current chart and the panel name, which happens to be a title also, followed by a sub-window variable. We then assign the panel position coordinates. Since the create function returns a Boolean value, true for success and false for failure, we can call it within an if statement checking its value. The exclamation mark checks whether this function has returned a false value. If it has, we return a false value and prevent this function from executing further. To test this panel as we make changes, let us create an expert advisor for the task. We give it the name Informative Dashboard. And this new expert advisor will start by importing the library file. We then instantiate the class and assigning it to a variable named dashboard. To make matters interesting, we create an input section for X and Y coordinates. This way we can auto-resize the panel. Compiling this expert advisor returns an error indicating that we need to make the create dashboard function return a true final value when there were no errors in creating the dashboard panel. Inside the expert advisor, We now have to call the function to create the dashboard, followed by the one to run it. After compiling the code in debug mode, the panel should be up and running. As of right now, this dashboard cannot be moved. So we need to create the onChat event function as we did in the previous chapter. After successful compilation in debug mode, the dashboard panel should now be movable. We now have the X and Y coordinates on the input section. We can adjust the position and dimensions of the panel. After increasing the dashboard panel, as you can see, it breaks. This is simply because whenever the input of an expert advisor is changed, the onInit function is called, followed by the onInit function, which recreates the panel despite the presence of an existing one. To fix this, we have to call the destroy function inside the onInit function. This goes on to show how important are the 3 steps I mentioned in earlier chapters. After compiling the code, we shouldn't experience any issues after resizing the panel. These new dimensions for the dashboard panel seems to be fitting well. We can modify and increase the default values. Now that we have the dashboard container, let us start adding objects to it, starting with the account name. From label.mqh library, we extract the class label and assign it to a variable named account name. Once we have the account name label, we have to create a function to create this label and add it to the dashboard container panel. The function to create label has to be able to take the object as an argument, so we pass the label class with an ampersand key. To make matters interesting, instead of adding the coordinates x1, x2, y1, and y2, let us give the object x and y values for the initial positions. The ending position will be determined by the value width. Any object must have a unique name that MetaTrader 5 will use to distinguish the object from the other. We can create the argument named labelName for this task. We also want this object to show some text, so we create an argument named text. Now we have to declare the create dashboard function. To create a label, we go to our label class and get the create method. We pass the current chart variable, and for the unique name of the object, we pass the variable name mname plus the label name. Despite not being very practical, giving the object a name that is a combination of the dashboard name followed by the label name you want to assign it to can help avoid naming conflicts when you have multiple panels on the same chart having similar unique names. We add the sub-window variable. For the x and y coordinates, we pass the x and y variables to x1 and y1 respectively. Unlike when creating objects of a button type such as the input field and the button itself, labels don't follow the typical coordinates for the ending positions x2 and y2. This is simply because a label is just a text. Its ending position depends on how long the text is, meanwhile, its height depends on the font size. For the ending position along the x-axis, the x2 variable, we give it the same starting position value, which is x, but for the ending position along the y-axis, We can give it a random value such as the initial y value plus the width. It doesn't matter. The label create function returns a Boolean value, true for success and false for failure. We can check if there was a failure in label creation and return a false value to prevent this function from further executing. Shortly after creating the label object, we must add it to the dashboard container. We do it by calling the add method from our parent class. This method also returns a Boolean value, so we check for a false value and stop the function if there is a failure. Finally, we can add the text to be displayed by the label object. The text method is a Boolean function, so we wrap it within an if statement just like the prior two. Finally, we can return a true value if the function executed successfully. Inside the create dashboard function is where we want to create the account name label using the function we just created. We hand over the account name label. Let us give this label the value of 20 for both X and Y. For the width, let us define a variable width and give it a value of 10. For the unique label name, we write AC_name. For the text to be displayed by this label, we want this to display AC name, which stands for account name. After creating a panel and all its objects, MetaTrader 5 can delay showing these objects on the chart, which can be very annoying. To prevent this situation from occurring, we can call a built-in method named chart redraw. This simple function reinforces MetaTrader 5 to draw and redraw all the objects immediately on the chart. Let's compile our main file and see the changes we made. As you can see, we have a fancy label that sticks with the dashboard panel. Let us proceed to add another label, which is the daily profit and loss label. We copy and paste the account name label and modify the parameters. Give the text to display for this label to daily PL. For the unique name, we give it daily_PL. We don't have an object for this label, so let us define it. We then pass this label object to the function. Since we want all the labels to be in the same position along the x-axis, but in a different position along the y-axis, we only modify the y values. Let us increase the y value for this one to 40. After a successful compilation in debug mode, you can now see we have a second label, which is daily PL. It seems that we have a bigger dashboard than the information we want to display, so let us reduce the unwanted space by resizing it down. It seems fine. Let us proceed to create other labels following the same principles. Yes, we now have all the labels we need in our informative dashboard panel. Now let us create their actual values. For instance, after the account name label, we want to display the actual account name. We follow the same principles, so we can copy all these labels and paste them below. For these second labels to display the values introduced by their preceding labels, we have to modify a few parameters such as the text to display, their unique label names, assigning a new position along the x-axis for all these labels, not to mention modifying the label object. We head back to where the labels were defined and create other labels similar to the one we created. The new labels will have slightly different names from the ones we created before. These new label names end with the word underscore value. Now let us create new labels for these new object names. Now we have to modify their starting position along the x-axis. The starting position along the x-axis for the first labels was 20. We have to give a new starting position along the x-axis for the new labels. Let us set 100 as a new position along the x-axis for these labels. After compiling the program, there is a typo coming from the definition of a variable named daily PL underscore value. After fixing the issue, everything should be fine. We now have to change their unique label names into different names. Let us compile the program and observe the new changes. We now have two sets of labels in our informative dashboard. As you can see, some of the labels are not well arranged. We have to move the percentage drawdown and the position and orders labels forward a little bit. We also might want to move the spread label value back a little bit. Let us increase the starting position along the x-axis for these two labels from 100 to 110. We also reduce the spread label starting position along the x-axis from 100 to 80. It looks a lot better. Now, let us make the second set of labels we just created display the actual values we want. Starting with the account name. Let us display the actual name of the account. There are various ways you can get the account name. So far, the easiest way is to get the account name from my built-in method account info string. We assign the account name variable into a string named AC underscore name. Then we pass this string to a text section of the object to display the account name value. Unlike the account balance label value, which is fixed and cannot change until the program is reloaded, values for the rest of the objects such as the daily profit /loss, the percentage drawdown, The total number of positions and orders and the spread value needs to be updated very frequently and often. It is not ideal to assign a value to these objects while they are being created. We can set these values to 0 initially, then modify them afterward. Let us compile the program and observe the changes. We now have an informative dashboard displaying the actual account name of a user and the rest of the variables set to 0. To be able to update these values frequently, we need to make a function that will help us with this task. This function must be called within the onTick function. As we know, in MQ5 and MetaTrader 5, it is only the onTick function for expert advisors that can run the code on every tick, literally every second. Let us create the function named refreshValues for the purpose of updating our label values. We can then declare this function at the end of our class. Starting with the daily profit or loss value, let us update its value. To update the value of an object, you simply call the method text from that object and pass to it a value in string format. To understand in great details how the labels can be updated, let us make this daily profit or loss label display the current time. We pass to it the current time built-in method. Inside the onTick function of the expert advisor, we want to call the function refreshValues. After compiling the program in debug mode, we should be able to see the daily profit and loss value display the current time. Now let us make this label display the actual value for daily loss or profit value. At the end of our library file, I just pasted a function named dailyPL that I copied somewhere else. This function calculates the daily profit or loss. It starts by selecting all the trades in history from the beginning of this day to the current time. It then loops through all the closed deals that occurred today, checking if a trade or a deal has already been closed. Upon detecting that a deal is closed, it obtains its profit or loss value. It then sums up that value to the variable named daily profit. In the end, this function returns a daily profit or loss value. Finally, we can call this function to display the daily profit or loss value. Now let us compile the program in debug mode to see the outcome. As it can be seen, the daily PL, which stands for profit or loss value, is showing that we made minus 1.6 loss. So let us check if this is true by looking at the history section. It is indeed true that we have made minus 1.6 loss today. To prove this further, let us pull up one-click trading and open two opposite trades, one for buy and the other for sell. We want to close these trades real quick. You can see the loss has increased. And if we close the other one, the loss has also increased. So we made a total minus 2.9. We need to control the double variables when displaying them on the dashboard. As you can see, the profit or loss value has gotten out of its place just to display the value with precision. We can trim this value into three significant figures. The method double to strings set to 3 digits will do the job. Now let us proceed to make the percentage drawdown label display some value. We calculate the drawdown percentage using the formula equity minus balance divided by balance, then the outcome multiplied by 100%. Despite the formula not being ideal, it lets us know how much of the equity in percentage is down based on the account balance. We calculate the formula in MQL5 and display the outcome, without forgetting to trim the significant figures to 3 using the method double to string. For the level positions and orders value, we want to count the total orders and positions running in the account. The outcome of this summation is an integer variable. We can simply cast it to a string. Finally, we can get the spread label to display the spread information from the market. We can get the current spread from the market using a built-in method named symbol_info_integer and extract the spread. After casting the spread information into an integer, we recast it into a string and pass it to the spread value object. We forgot to put a semicolon here. Also, the variable spread has already been defined, so let us modify it to something else like market spread. Let us compile the program in debug mode and observe the changes. Let us open some trades and observe the updates in the informative dashboard we have. After opening some random buy and sell trades, you can see the number of positions and orders are now 3, which is indeed true. You can even open a pending order. You can see the number of positions and orders has increased to 4. We also have the spread value from the market, which is 8. We can make the panel interesting by adding some colors to it. Let us make the account name label and its value in Dodger blue color. To add or change the color of an object, we call the method color from the object and pass to it the color we want. We also have to change the color for the account name value label, as these two go together. After compiling the program in debug mode, we should be able to see the account name label and its value in Dodger blue color. Additionally, we can make the daily profit label display its value in red color whenever the daily profit is a negative value, indicating that we made losses today, and make it display Dodger blue color when the value is a positive one, indicating that we made profits in the current day. And since this is a conditional statement that needs to be rechecked every time, we need to program it within the function named refresh values. Here we can create an if statement to check if the daily profit is a negative number. If it is, we display the daily profit label value in red. Otherwise, we display this label in Dodger blue color. But first, instead of calling the function dailyPL once more, let us assign the value obtained to a label named dailyPL underscore val. Then we can proceed with an if statement. Let us compile the program in debug mode to see the changes we made. As you can see, the daily PL value is in red color as we made the losses today. Shortly after the daily PL value becomes a positive one, this daily PL value will be in Dodger blue color. I am excited to welcome you to my latest course where I guide you step by step through creating simple to advanced dashboards and interactive panels. You start by learning the basics. How to create simple dashboards to display account and trading information efficiently. These dashboards will give you quick access to the trading data that matters the most. But we won't stop there. Once you master the basics, I show you how to level up your skills by designing complex panels with multiple menus and sections, giving you full control over your trading interface. From navigating market data to creating an interactive panel for executing trades, this course will take you from coding simple dashboards to designing professional-grade dashboards and panels. By the end of this course, you'll be able to build customized dashboards and panels that aren't just beautiful, they are incredibly useful for enhancing your MetaTrader 5 trading robots and indicators. So, whether you are an intermediate or experienced coder, join me in this exciting journey to mastering dashboards and panels in MetaTrader 5. Let's make your trading experience smoother and more powerful.